All right, welcome to this video. This one is going to be the first one on our non-renewable energy sources. So I just wanted to start out with this image. We're going to specifically be talking about petroleum and crude oil today. And so this is something that could eventually economically run out, and it's something we need to be prepared for. So this is kind of where our energy comes from for the world. Oil is the one we're focusing on here. So it makes up about 33% of energy for the world. A lot of that's transportation. Same is true for the United States, a little bit heavier reliance on oil than the rest of the world. And so oil, along with coal, is essentially a fossil fuel, and it's called that because it does come from a fossil. And so this is what happened millions of years ago. We had plants, whether they were phytoplankton or woody vegetation, dying and falling to the bottom of the water. And so by sedimenting their dead bodies on the bottom, it eventually got covered up before it could fully decompose, and so we only have partly decomposed matter. And over time, those carbon bonds are broken, and we're forming something called kerogen, which is one of the precursors to oil and coal. And so there's a couple different processes, but essentially they get heated and pressurized deep underground under all those sediments, and that's what forms our fossil fuels. They are our dominant source, and so just some statistics for you here. Electricity is primarily coal produced right now. Coal is great for producing electricity because it has a lot of energy returned on energy invested. It's very efficient, and with coal, you can transport it very easily. It's very stable. It's actually a physical object, solid. It's kind of like a rock, black rock that you can burn, and it contains a lot of energy in it. Natural gas is another big supplier of electricity. This is on the rise lately as we're doing more fracking and stuff in the United States. But so this is kind of why we like them down here. They're very energy high in energy content, and we can ship and store them. This is a really important part. We can store them very easily and transport that energy from one place to another. Electricity is a secondary form of energy. It's very useful to transfer the energy we get from the fuels into something productive for us. Remember, each time we transmit it or transfer it into something else, like coal, chemical energy and coal, into secondary electrical energy, we're losing some of that energy through loss of efficiency. So the question that I always get asked here is, how long do we have for oil? And so the thing with oil production is we're not really sure how long it will last, partly because some of the countries that own a lot of the oil supplies don't fully release their numbers. But BP every year puts out an annual report, and they kind of estimate our oil reserves as 1.688 trillion barrels of crude oil. And so if we didn't change anything and we stayed using oil at the same exact rate that we are today, so we're not increasing our fuel economy of vehicles, we're not reducing the number of cars on the road, everything stays the same, that amount of oil that BP says exists in the world would last for a little over 53 years. And so this is actually from last year's annual report from BP, so that number would be -1, 52.3 years. And so it's likely that this could be phased out during your lifetime, which is an interesting but also kind of scary to some people's prospect. So now that we kind of know how long we have it for, let me talk about what it really is. And so when we extract it, it's closer to this form, but it's a very thick liquid. It's got these hydrocarbons in it, and so hydrocarbons means there's a lot of carbon atoms, a lot of hydrogen atoms bonded together. Those bonds are what stores a lot of energy, and when we break those energies by burning this fuel is when we're releasing that chemical energy. They're found deep underground, sometimes under the ocean, and we can use it for a lot of different things. And so of all the resources of oil out there, typically this is what you can expect from a deposit, 30 to 50% economically recovered, and we'll talk about that process in a little bit. As price goes up, of course, the number or the amount of economically recoverable oil will also go up, right? The more you can sell it for, the more cost effective it is to mine more out. And so as we get more efficient at extracting oil from the ground, we can reduce that net energy yield. And so that means that as we reduce the net energy yield, we're actually making more energy than what we put in. So the history, we've used it for a long time. There's actually ancient history, thousands of years ago, using oil in the solid form, tar, typically for kind of ships and also for lighting fires and stuff. The tar would be used in ships to make it watertight and kind of seal the wood together. Um, More recently, in the 1850s, is when it was first kind of discovered as a liquid form, and we were actually drilling for oil, and it was actually sold as a medicine originally. And there was a guy named Edwin Drake, who drilled the first oil well. It actually was up in Pennsylvania in 1859. And eventually it's kind of grown to this massive energy resource for us, and we rely for it, or we use up a quarter of the world's oil on a yearly basis, so we're the biggest demand for oil. It's a mixture of a lot of different things, so there's not one chemical formula you can use for petroleum. There's a lot of different hydrocarbons in it, a lot of different length hydrocarbons in it as well. Typically you're going to find about 1 to 2 miles underground, and like we said before, it comes from that sediment, the dead organic material buried in marine sediments. This is the process for finding oil. So this layer here and this layer here would be impermeable rock layers, and it would hold the liquids inside it here. And so just due to the densities, typically you're going to have natural gas forming on top of the oil. You'll have the liquid crude oil below and then water down below that. And so this vibrator truck is able to send seismic vibrations down, and based on how those vibrations reflect, the recorder truck can identify how deep the deposits are and how viable they are. And so if we find an oil deposit, let me clear this off here. If we find an oil deposit and we build a well right into that oil deposit, so let's say there's our well for pumping that oil out, the pressure above is usually enough to force the oil out. And so what you see on those old Western movies where they discover black gold and it's spraying up in the air is actually something that could happen, because you've got a lot of rock weight pushing down on that sample of oil. One thing that they will also do, so if we extract oil here, this might not be the smartest placement, because once our oil is depleted to this level, we'll kind of run the oil dry here. And so typically you're going to see them place these up into the top of the deposits. And then once we get that secondary extraction, so primary extraction, we recover everything we can at the current economic price. But as prices increase, especially in the last couple years, it becomes more viable to go back to these old wells. And there's actually secondary extraction where they can pump water down into this gap, this deposit between these confining layers, and it will force that extra oil up and out of the pipe, and you can kind of get some more. So exploratory drilling, this would be like searching for the deposits, and so they might place a lot of these in a certain area, spread out to try to map how big of a deposit they have below and how viable it would be to mine there or extract it there. I kind of went into primary extraction. The other part of secondary extraction are the solvents that they use, and so there might be some kind of organic solvent they send down there into the deposit to dissolve the oil into it, and then by pumping that liquid back up, they kind of get a little bit more out. No matter what though, no matter how extensive our secondary extraction is, we're never going to get every bit of oil out of the ground. There's always some that'll be left behind. And typically it's due to the cost, and so as the cost of oil increases, the more money we can spend getting it out, and that means we can get a little bit better and a little bit better and a little bit better. But lately the cost of oil has been decreasing, and so it is reducing that economically recoverable resource. So this is the process after we get it out of the ground. Once we get crude oil out of the ground, it goes through this. This is a distillation column, and so based on the boiling points, essentially you've got a furnace down here which is going to boil the crude oil, which is a liquid, and so it'll boil just like any other liquid. And they've got these columns that'll separate it into different weights, and so you get kind of groupings of similarly sized molecules in these. The heavier components are going to sink out, and I like this picture because it kind of shows where each of these different things go to. And so the real heavy components of this, you can see, are very, very solid substances like asphalt and grease and wax. But as you get up lighter, this would be like natural gas, like propane, very small hydrocarbon, only a couple carbons and hydrogen atoms in it, where something like asphalt would have hundreds, if not thousands, of carbon atoms per one molecule. And so this is how we separate it out. Important to know kind of the different levels on which comes out where. Like gasoline is going to be one of the lighter compounds and will come out near the top, and diesel a little lower, and so on and so forth. This is an interesting little website, so if you get a chance, type it in and check it out. I thought this picture was interesting, just with the number of different things that come from oil. And so it's important to remember that everything we use that's made out of plastic eventually came from oil at some point, and then is refined in a different process and extracted and created into all these different kind of useful things. While we're talking about oil, it's important to mention OPEC. And so OPEC is a group of countries that have the majority of the world's oil reserves, 78% of the world's proven oil reserves. And they also have a lot of unproven reserves. One thing with OPEC is they don't like to release their numbers, how much oil's left in their reserves. And so that kind of gives them a power over the people that are buying oil from them. They can kind of fix the price to what they would want it to be. And so they can use that to push other energy companies out of the market, companies that might be investing in renewable energies or in natural gas energies, which I'll talk about in a little bit here. So by controlling this here, they really have a lot of power over the countries that rely on the oil, which is why you hear a lot in the United States about reducing our dependence on foreign oil and being prepared, because a lot of our energy, as you saw, we use 25% of the world's oil, and 39% of all our energy comes from oil. It relies on getting oil from these countries. And so if they were to shut the supply off or greatly increase the price of it, we'd be in a lot of trouble. So these are the OPEC countries. I'm not going to repeat them all, but feel free to pause and check them out. Here's our oil production and oil consumption percentages. You can see United States consuming 24% of the world's oil, far and ahead of everybody else by a significant margin. We also produce a lot of it, but remember, this is going to include things like ethanol and natural gas in there, which is why we're so high on that list. These are the numbers for how much they have, which is the proven, the darker color, and then the unconventional oil reserves are the taller numbers. And so you can see that there are areas that have a lot of unconventional supply, especially South America here in that shale oil. Hubbert's curve is an interesting thing to point out. So this is a prediction from a scientist named Hubbert. And what he predicted is that as you discover a substance, a mineral resource, something like that, eventually you're going to increase your efficiency at extracting or locating it. And so you're going to see this general upward trend. At some point, you're going to get really, really good at extracting it, to the point where you reach the peak where you've used up 50% of that resource. And then from that point on, you're never going to be able to achieve that former production number. So we're producing here at 0.25, but we've gone over half of all of the resource in the world, and so there's not that much of it left, and so it's going to start dropping and dropping and dropping and dropping. And so this is a prediction they use to apply to oil, especially here in the United States. You can see we peaked out, according to this graph, right around 1970, a little after the 1970s. And so it matches pretty well with that prediction of what happens to peak production, or eventually where you exceed the 50% mark of all the resource, and then you decline from there. Here they are overlaid, and you can see just how well they line up. It's kind of amazing how closely related they are. But what this is essentially saying is that we're eventually going to run out of oil in the United States. This is our production here, and we're going to then increase our foreign dependence on oil, which has some downsides to it. It's not just a United States problem. If you look at worldwide oil production, you can see a very similar peak, although it's peaking closer to 2010, and you've got some predictions on the end here. So we're not really sure if the Middle East is going to quite tail off like this, or some other factors there. But it's predicted that we're living right now in the age of worldwide peak oil, and so that has some frightening associations with it, like I said in the beginning, that in the next 50 years we might run out of oil would also have similar thoughts about it. And so these are some consequences of it. The demand and the supply are not going to be able to meet up eventually. That supply is going to drop way down and the demand will shoot way up. And so you're going to get these really big consequences where some people can afford oil, some people cannot afford oil. Do we have worthwhile alternatives? And so we rely on it to transport our goods. A lot of our economy relies on being able to move goods and people from places to another. And so the thought is that if oil prices shoot way up because the supply is so low, that the suburbs living outside the city is actually going to be the downside, and so that'll become the new slums. And so you end up with this wasteland of destroyed cars and criminals and like wasteland marauders and stuff. Some more optimistic people argue that as the supply dwindles and the demand rises up, you'll see a big increase in alternative energy, and so we'll kind of spare ourselves from further adjustments. And so we will face an oil shortage in the near future. Like BP predicted, sometime in the next 50 years, it's expected to really seriously run out or get low. Peak oil is very difficult to predict, though. And so in the United States, we can predict that we've passed peak oil for our production, but worldwide, with those countries that aren't willing to share, especially OPEC, we can't say for sure that we're there or that we're close to being there yet. But it appears signs point towards that way. These are crude oil prices. I'm going to skip over this one in interest of time. I thought these were telling. This is 2005, or 2015. This is last year. This is 2016. This is this year. And you can see the price for oil was about $50.90 last time I taught this lesson. And right now, a barrel of oil is $37.74, but that's after having a pretty significant jump in the end of February here. So the price of oil is decreasing, which is a really interesting thing I'd like to talk about in class. So please come with some notes and be prepared to discuss. Thank you for watching.